let's go ahead and try problem number 2 from the practice sets on page 231. And the problem says, express the strength of a calcium chloride solution in the form of a fraction, a ratio, and a percent if 250 milliliters of solution contain 100 grams of calcium chloride. So we're going to apply the formula that the strength of a solution is equal to the amount of solute. In this case, the solute is 100 grams of calcium chloride divided by the total amount of solution, which is 250 milliliters. Okay, I'm going to start by writing this as a fraction. So we have 100 grams of solute, okay, over 250 milliliters of solution. Okay, what we now want to do is simplify the fraction, and then we'll have the strength as a fraction. Okay, so 100 over 250. You can try to simplify that by hand. Okay, or if you have a calculator that can deal with fractions, I would suggest using your calculator to simplify for you. So 100 in the numerator, 250 in the denominator. Okay, when simplified is equal to 2/5. Okay, so this is equal to the fraction 2/5. Okay, so as a fraction, the strength of the solution is 2/5. Okay, once we have the simplified fraction, right, we can easily write the ratio. Okay, so the ratio would be 2 parts solute, right, to 5 parts solution. And then to express the strength as a percentage, okay, we're going to take that fraction 2/5 and multiply it by 100%. Okay, so we're literally going to do 2 divided by 5 on our calculators, and we should get a decimal there, so 0.4. Okay, and then take that 0.4 and multiply it by 100. All right, and we can see that as a percent, the strength of the solution is 40%. So in this problem, we determine the strength of the solution with a dry solute, okay, because the units of measurement for the amount of the solute was given in grams. Okay, now if this was somehow given in milligrams, right, you want to convert it into grams first, and then simplify the fraction from there. And then once you have the simplified fraction, you can write the ratio, and then to get the percentage, take the fraction, divide the numerator by the denominator, multiply by 100, and then you have the percentage. Okay, so let's go ahead and take a look at another problem. Okay, so this was going to be on page 232. And we're going to go ahead and do exercise number 11. And keep in mind that the page numbers in the ebook may be different than in your hard copy of the book. Okay, but in the case, this is number 11. Okay, the problem says, how many milligrams of this drug are contained in 200 milliliters of a 0.2% solution? Okay, so this is the type of question that's asking how much solute is in a given volume of solution. Okay, where the given volume is 200 milliliters, and then the strength is 0.2%. Okay, so we're going from milliliters into milligrams. Okay, so to go from milliliters to milligrams, we're going to use the strength of the solution in our calculation. Okay, which means that when we use the strength there, okay, let's go ahead and write it as a fraction, so 0.2%. okay, when written as a fraction, okay, is equal to 0.2. grams, okay, over 100 milliliters. So remember, in cases of solutions of the dry solutes, okay, the units for the amount of solute are always in grams. Okay, even though the problem is asking for the number of milligrams of the drug. Okay. Alright, so the numerator we have 0.2, and then the denominator is 100, so 100 milliliters. Okay, and we can quickly see that, okay, when we do 0.2, okay, and multiply by 1,000 milligrams per gram, okay, we can quickly see, okay, that this fraction is equal to 200 milligrams over 100 milliliters, okay, which you can actually simplify. I'm not going to worry about simplifying it now, okay, but basically this equates to 200 milligrams in 100 milliliters of solution. Okay, so once we have our strength, okay, now we're going to use that to convert the 200 milliliters of solution into milligrams of the drug. Alright, so we're going to use this fraction here, 200 milligrams over 100 milliliters. Okay, feel free to simplify that, although you don't have to. Okay, so I'm going from milliliters to milligrams. Okay, the units of 200 milligrams are going to be on top. And then 100 milliliters in the denominator of that fraction. Okay, so in the dimensional analysis approach, right, we can see that milliliters cancels the milliliters. And then the units we're left over with is milligrams. Okay, so we can put that in our calculator. So 200 times 200 divided by 100. Okay, it's given us 400. So in other words, right, there are 400 milligrams of the drug in 200 milliliters of solution. Okay, what we did to solve this was we first took the strength, okay, which was expressed as a percentage, right, because this is clearly a dry solute, right, it's asking for the number of milligrams of the drug, okay, so then we wrote it as 0.2 grams over 100 milliliters, and then once we had that strength, right, we took the 200 milliliters, multiplied it appropriately, and we got the milligrams. Now, another way you could approach this is you can take the 200 milliliters, okay, multiply by 0.2%. Okay, so most scientific calculators have a percent function. Okay, so when I do 200 times 0.2, right, I'm multiplying by 0.2%. Okay, and what that percent is going to do is it's going to convert that 0.2% into a decimal. Okay, so when we do 200 times 0.2%, okay, we get 0.4. Obviously, that's not the answer. Okay, so remember that with working with dry solutes, right, the units, the amount of solute is the standard unit of measurement there is grams, right? So when we do 200 times 0.2%, okay, we get 0.4, right? So in other words, there are 0.4 grams. So it tells you the number of grams of solute in the solution, which is 0.4. So remember, it was asking for milligrams, so then you would simply multiply it by 1,000 milligrams per gram, right? And you need to get the same answer. Okay, so not all calculators are the same. So for example, when you type in 0.2 and hit the percent function, okay, it's going to give you that decimal. And then you take the decimal, multiply by 200, then you really get the 0.4, and then take the 0.4, multiply it by 1,000 to get the 400 milligrams. Okay, let's go ahead and move on to the next problem here. So we're going to take a look at number 16. Okay, and we have to read the figure in order to do the problem. And the problem says, read the label in figure 8.13 and determine the number of milliliters of the solution that would contain 250 milligrams of this drug. Okay, so we need to read the drug label to determine the strength. All right, and this is the strength of the drug here, so 200 milligrams per 5 milliliters. So remember, strength tells you how much of the drug are in a certain number of milliliters of the solution. Okay, and it does say up here, right, this is for an oral suspension. So an oral suspension is something that has to be pre-mixed before you serve it to the patient or give it to the patient. Okay, so anything that's mixed is a solution. Okay, so the strength of the solution is 200 milligrams and 5 milliliters. So let's make a note of that. So the strength is 200 milligrams and 5 milliliters. Okay, which you can simplify as well. So 200 milligrams over 5 milliliters. Okay, I'm gonna go ahead and leave that unsimplified. Make sure I got it correct here. So 200 milligrams and 5 milliliters. All right, so we want to go from 250 milligrams into milliliters, right? We want to know, okay, how much of the solution will have 250 milligrams of the drug, right? Perhaps, so we know, right, how much to administer to the patient. Okay, so we're going to start with the 250 milligrams, which is perhaps part of a drug order to give to a patient. Okay, so since we're going from milligrams to milliliters, okay, we're going to multiply by 5 milliliters over 200 milligrams. Once again, simplify the fraction as necessary. Okay, it might make the calculations easier, but I'm going to go ahead and leave it unsimplified there. So we're going to do 250 multiplied by 5, and then divide by 200. Okay, so we can see that 250 milligrams of the drug, to give 250 milligrams of this drug, right, you need to administer 6.25 milliliters. So 6.25 milliliters. Now keep in mind that depending on the device you use to administer the medication, right, it may only be accurate to 1/10 of a milliliter. Okay, so in some cases you may see the answer rounded to the nearest tenth here. So if that's the case, if the answer is rounded to the nearest tenth, right, then it would be approximately 6.3 milliliters rather than 6.25. But the exact answer is 6.25.